Now this problem says use the substitution b plus x to the r power to equal this quantity b plus a to the r times the quantity 1 plus x minus a over b plus a to the r and the binomial expansion to find the Taylor series of the given function and center. All right, so the function here is square root x plus 2, and my center is a equals 1. So in essence, all I'm going to do here is plug everything in. The first thing to notice, though, with this problem is this x square root of x plus 2 is really x plus 2 to the 1/2 power. And I think, honestly, that's the trick for this one. Because now I know that my b here is 2, as you can see. My r is 1/2. And essentially, I'm just going to plug that in my formula here. So I have b plus a here. So my b is 2. So that's going to be 2 plus a is plus 1. To the r is 1/2. And then I'm going to have here 1 plus, and then x minus 1 on top, and then a plus b is going to be, or b plus a is going to be that 2 plus 1 again, and the r is 1/2. All right, so I'm going to simplify this a little bit. So then that's really going to be 3 to the 1/2 power. And this in here is going to be 1 plus x minus 1 over 3. And that's going to be to the 1/2 power. Okay, and then all I'm going to do now is plug that into our handy dandy formula. Because the way I look at this is really just 1 plus x to the r here. And that's how I see that piece right there. So what does that mean for us? And instead of x, I'm going to put in x minus 1 over 3. So in doing that, when I look at this next series then, this series is going to be n equals 0 to infinity. And then my, oops, I forgot one thing here first. I should put the 3 to the 1/2 here. And then I have the series n equals 0 to infinity. And then I'm going to have the 1/2 choose n. And then I'm going to have, instead of this x to the n, I'm going to have x minus 1 over 3 to the n. So then we can clean this up a little bit more. I don't know if it's really cleaning it up, but I got 3 to the 1/2 out here. N equals 0 to infinity. 1/2 choose n. And this is going to be x minus 1 to the n over 3 to the n. Another thing I can do is I could, in a sense, put these 3's together, because one's on the top, one's on the bottom there. I can think of that as three to the 1/2 over 3 to the n, and 1/2 choose n x minus 1 to the n, and then that could give me n equals 0 to infinity of 3 to the 1/2 minus n to the 1/2, well, of 1/2 choose n, x minus 1 to the n. I could write that. So it's another way I can write it. Just different ways. I think I would be okay if you made it this far on a test. So there's your answer.